Alright, so I'm going to go over one of the forms, which is in Google Classroom labeled just as the 4.5 worksheet graph trig other version A. So first we're going to start with number 5 because we should know 1 through 4 already. So we're going to try to graph the secant of x. If we remember, secant is one of the ones with our upwards and downwards facing u's, and secant is the one that kind of centers over the y-axis. So domain and range are a little bit complicated. Let's start with our amplitude. We have no numbers added to our function here. So amplitude is 1. Period is, for secant, 2 pi, that's correct. Phase shift, there's nothing, so we can just put NA. Vertical shift, again, there's nothing added, so NA. And then asymptotes, we'll come back to that. For that one, we said it gets tricky. So since there's no changes here, I'm going to draw our y-axis right down the middle, and then our x-axis right down the middle. All right. Our amplitude is 1, but remember for cosecant and secant, we kind of want that to be about halfway through our y-axis, so that would be 1 and -1. And then we need to figure out where to put our vertical asymptotes. So we know that we'll have one at the start of the period, one at the end of the period, and then one halfway through the period. So what we should be always doing when we're ever graphing trig functions, we take our period, which is 2 pi, and divide it by 4, and that will give us a good approximation for what our tick mark should be. So we'll get pi over 2. So looking at this, I need 2 full cycles. So if I count over to the right, I have 4 red lines, and then to the left, 4 red lines. So that might be good enough. I'm just going to go with every line period, so that way I don't have to try to balance it. So that means every tick mark here that I'm putting on my x-axis is going to be pi over 2. So I'm going to try to think of a way to label it so that way I don't have to put pi over 2 on each thing. And since it's a little difficult for me to write on my iPad right now, I'm going to try to do it every red line. So that's pi, 2 pi, 3 pi, and so on. And on the other side, I might just put negative pi, and then we'll try to deal with that later on. So, for secant, I already said that's the one where it's centered on the y-axis, so that means we'll have a u centered on the y-axis. So for here, we need to figure out where does our period start. Our parent function, it starts at pi over 2. We changed nothing. We didn't change the period. We didn't have a phase shift. So we are still going to have a vertical asymptote at pi over 2. So then we add 2 pi to that. So, sorry, at negative pi over 2. So then we add 2 pi to it, which would be 4 pi over 2. So negative pi over 2 plus 4 pi over 2 would be 3 pi over 2, which would be right here in between pi and 2 pi. So that would be the start of the period, the end of the period on the right, and then we do need a vertical asymptote halfway through. Alright. And then we determine where to put our u. We go an amplitude up in the middle. We didn't do anything tricky here, so there's our u. And then in the other one, it starts at an amplitude below, and we want it to touch that dot and then come back down. So that would be one cycle. We can go in either direction for the other cycle. I have more space on the left, so I'm going to put a downwards facing u right to the left, and again go through the dot, and then another vertical asymptote, and that's half a period away. Count an asymptote up, and then upwards facing u. So that would be 2 cycles of our secant x with no transformations. Moving on to number 6. We have just tangent. So tangent is one of those tricky ones. It's not a U, it's not a curve, it's all those S's. So let's try to fill in, oh, I'm sorry, we did not fill in the rest of number 5. So range, we can see here we would start at negative infinity, and then as I said in class, we go to d minus amplitude, so negative pi union 1, and then we go to positive infinity. Domain is a tricky part. It's where x cannot equal, and then we'll put where our vertical asymptotes are, and here our common difference is half the period, so pi. So we would do pi k, and then we just pick up one of our vertical asymptotes, which I always like the one that we start our period with, which was negative pi over 2. And then down here at vertical asymptotes, it's the same thing, but just an equal sign instead of a not equal sign. So pi times k, which remember we said k is just any integer minus pi over 2. Alright, so let's move on to the next one. I'm going to try to flip my screen so that way we get a little bit more space. There we go. Okay, so moving on to number 6. Moving on to number 6, now we finally have tangent. So as I was saying, it's the one with the S's. We have 3 dots that we need to graph, and our period is going to be different. So let's start filling that out. We can always say our range for tangent will be all real numbers. And then our amplitude is just like what it was for everything else. So 1, our period, we do pi divided by b. So here that's just going to be pi because we don't have any numbers added to our equation. Our phase shift, again, nothing. Sorry about that. Our vertical shift, nothing. And as with the others, we'll come back and try to deal with our domain and our asymptotes in a second. So not a lot going on, so we can just draw a normal x and y axis. So smack dab in the middle. And then let's try to figure out how to graph this accordingly. So we can put our amplitude again here just right at the middle marks of our y-axis, and then we can try to figure out what goes on the x-axis. So our period is pi. We're not shifting, we only need 2 periods, so we can be quite spacey with this, and we can put pi kind of every other red line. So that'll allow us to kind of space things out. For tangent, it is centered over the y-axis, so that means our asymptotes will be on either side. We want it centered, so the period has to be centered on the y-axis, so that means we have half of the period on the left and half of the period on the right. So I divided my period, which was pi, by 2, because I have to half it, and then that means the left asymptote will be at negative pi over 2, the right one will be at positive pi over 2. And then for tangent, we have 3 dots. This middle one that goes halfway through the period goes right at the x-axis. And then the one on the right, we go up an amplitude. The one on the left, we go down an amplitude. And then we kind of just connect it with an S-looking curve. Likewise, to draw another cycle, we would go over a whole period, which would be pi. So we could do this on the left or we could do this on the right, since we have space. And then again, middle dot at the x-axis. If I go to the right a quarter of the period, I go up an amplitude. To the left a quarter of the period, I go down an amplitude, and then I just connect those three dots. I'm going to cut the video here. I'm sorry, after we find the domain and asymptotes, and then pick up on the back in a different video. Our domain is, we just have to figure out where are those vertical asymptotes, so we can start with that first. X equals, and then here, still same method, what is the common difference between the vertical asymptotes, and that would be our period, so that's pi. So we would have pi times k, and then we can just pick any asymptote. Here I'm just going to stick to doing where our period started at, so that's minus pi over 2, because I'm talking about this vertical asymptote right here. So then domain is the same thing, we just change it to a not equal sign, because it could be any number besides where our vertical asymptotes are. So that's pi times k minus pi over 2. All right, I'm going to pick up on the back in a new video, and then I'll see you on Monday.